How we doing? This is Mr. Murray coming to you with a homework recap for the factoring, intro to factoring handout. Please keep in mind for this handout, I'm going to only be focusing on the second page. So there was actually a couple pages. You did 1 through 12 was page 1, and that mostly focused on when the a value, and in this case you see a coming up a few times, so that is when the number in front of the square, the thing squared, was 1. That was most of the first page, but we're starting to really turn up the heat, and so we're going to have to deal with situations where sometimes that number is going to be bigger than 1. Okay, and so I was just seeing a couple things in the homework that I still need to address, and which I would ordinarily address in class, but unfortunately that's not a possibility right now. Okay, so the first one I'm going to think about is I got b squared minus 6b plus 8, and again my strategy is I'm going to make my box. Okay, and this is my b squared, this is my 8, so I know that this is a b and this is a b to get the b squared, and now I need to get the rest of it. So I need to figure out, how can I multiply two numbers and get 8? I could have 8 times 1. I could have 4 times 2. Notice that they both need to be positive. Oh, no, they do not. They actually both need to be negative, because a negative times a negative is a negative, or rather is a positive, and a negative plus a negative is a negative. So it basically means I've got to use -2 and -4. So my final answer is b minus 2, b minus 4. And because I'm only asking you to factor, you're leaving it like this: b minus 2, b minus 4. Okay, I don't really like b. B looks a little bit too much like 6 sometimes when you write it out, so I probably wouldn't go with b personally, but these guys took a different perspective. All right, notice the difference here. So notice this is minus 6 plus, rather the b is minus 6. Here the only difference is the b is positive 6. Okay, so just to fill this in, so you can see we get. So now this is actually going to be the same thing basically, except now let's think about it. So I've got my n squared. So we do have different letters, but that, like, from a conceptual, like, idea standpoint, doesn't really matter what you call the letters. Okay, as long as you use this, as long as you're consistent. Okay, in other words, if I was to switch this to m or x or c, the idea behind the factoring and the intercepts and all that wouldn't change. Okay, now instead of doing -4 and -2, I'm going to do +4 and +2, because again, a positive can only be obtained when multiplying if you have a negative times a negative or a positive times a positive. Okay, but if I'm adding the numbers and I get a positive, that means both numbers had to be positive, and if I'm adding the numbers and getting a negative, both of the numbers had to have been negative. So I get 4n and 2n, which adds to a positive 6n. So my answer is n minus 2, rather n plus 2, n plus 4. Okay, so you can see that if I had made these n's, or 13 n's or 14 b's, you can see that they're very, very similar, but not the same. All right. Now, 15 and 16 are very special. Okay, and actually 15, 16, 17, 20, 21, and 22 are all special in this way. Although the a value, in this case, the a values are 2, 5, 2, 5, 2, 4. The a values are more than 1. These are special because you'll notice that all 3 terms are divisible by the a value. That is, this divisible by 2, 6 divisible by 2, 108 is divisible by 2, 5 is divisible by 5, 10 is divisible by 5, 20 is divisible by 5. Here's what I saw someone do. I saw someone go like this, and then just factor it and leave it. You cannot do that, because look what's happening here. You're dividing, but where's the fraction? Okay, or rather not the fraction. Where's the equals? What is it equal to? How come you're not, right? If you just do the division, you're taking it and you're changing it into another quadratic. And because there's not an equals on the other side, you're not balancing it out with anything. So what I'll tell you is the dividing by 2 can be a valid technique. But in this case, it is not, because I'm asking you to factor, to put it into intercept or factored form. I'm not asking you to solve, and I know you can tell because there's no equations here. So please, 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 if you are not getting an equation, do not do that, okay? Please. You will basically be right in mostly, but the problem is that your final answer should have that 2 in it, and if you divide it out, it will not. And again, it makes the quadratic different, okay? If you right now plug n squared plus 3n minus 54, if you plug this into a Desmos and this into Desmos, you're going to get 2 completely different graphs. They'll be similar, but they'll be different. And so what that tells you is these are not equivalent. So the factorings are not equivalent. So please, I know I spent some time to reiterate that, but there's a reason I'm doing that, okay? What you can do is you can write it like this. So I can pop out the 2, as you saw in the do now for 318, and this becomes n squared plus 3n minus 54. This you can do because I'm recognizing that 2 is still part of this. It still has a place in this. I'm not just getting rid of it, okay? So I'll write an arrow so we don't get confused. And now, how about we factor n squared plus 3? So I agree with you. It does make the factoring easier. No doubt. Because now I don't have to worry about the 2. I only have to worry about factoring n and getting negative 54. And it's a negative, so the only way to get a negative is one of the numbers has to be positive and the other has to be negative. And I happen to know that 9 and negative 6 multiply to 54 and add to 3. So what you would write is 2 times n plus 9 times n minus 6, or 2 n minus 6 n plus 9. Okay, if you leave it as n plus 9, n minus 6, it's not right, because twice of something is not the same thing as 1 times something. Almost never is that the case. Maybe like 0 is the only time it's true. Okay, so you can see again, I get 9n, negative 6n, that adds to 3n, okay, etc. Here's the other way to do it. Now, you can see that this is a very much more straightforward. When possible, and look, the motivation is good. Whenever possible, we do want to try to pull out what we call, in this case, a greatest common factor. So we call 2 that greatest common factor. You do want to pull that out, and you're right to want to make it simple like that, because it really makes the problem significantly easier, and we're about to see how. So I'm going to come up here and I'm going to do this one in green. Actually, I'll do this one in black because I don't want to imply one method is better than the other, right? And green has as like an essence of correctness that I don't want to portray, because neither method is more correct than the other. They're both equally valid to me. So now I'd approach, look, how do I get 2n squared? Well, the only way here is I've got to get 2n and n. That's the only way to get 2n squared. Then I swing out and I look at, like, how can I get 108? Well, it's a negative, so again, I got to have a positive and a negative. But what goes into 108? Darn. So it turns out it's not a very easy question to answer. I have some premonitions here based on how I already did it. And what I actually know is that 6 goes into 108 because 2 goes into 108, it ends in an 8. 3 goes into 108, the digits add up to 9, so it's got to be divisible by 3. 1 plus 0 plus 8 is 9. And if 2 divides a number and 3 divides a number, then 6 divides a number. And what you end up getting, the correct combination, would be 18 and negative 6. And you can see that if you do this, this becomes 18n This becomes negative 12n. And then when you do 18 minus 12, you get 6n. So here what you get is 2n plus 18 n minus 6. Now notice, these are equivalent to each other. They have to be, because I just used two valid methods to solve the same problem. And if both methods are valid, they must yield the same solution. So why do the black and the blue look different? The reason is because in the first factor on the black factorization, the 2 and the 18, right, there's a greatest common factor. So when you factor, if you find that any of the terms have a factor in common, you always need to take it out. When we say factor completely, what that means is that you keep breaking it down until you can't break it down anymore. So here I was done because the 2 you can't break down, the n plus 9 you can't break down, and the n minus 6 you can't break down. Why do I know the n plus 9 and the n minus 6? Well, there's no way to multiply two things and get n plus 9 except 1 and n plus 9. So that's as broken down as it can be. And in general, as long as there's no GCF, like with 2n and 18, if your biggest power of the variable is 1, almost certainly you are not going to be able to break it down. But again, you do need to check for greatest common factors, such as the fact that 2n and 18 both have a 2 that can be removed. And you see, once I remove the 2, you get the same answer. Here you get a similar thing. So we'll take out the 5 and we'll do n squared plus 2n plus 4. And then that one's a little bit easier to factor because I know it's, not an easy one. Is it even factorable? That's a good question. It might not be. Let's see. It might not be factorable. So let's see. Can we find two numbers that multiply to 4 and add to 2? That's tricky. As it turns out, if I was going to try to do this, so I'm thinking in my head, how can I make this work? What you should know at this point is it doesn't seem like it's going to work, right? Like how would I even get this to be 0 at all, right? It doesn't, or to multiply at all, because and add, right? It doesn't seem like it's a sensical problem. And, if you are someone who's skeptical and is starting to develop a sense of, this isn't adding up, you're right. As it turns out, if you were to graph this in Desmos, you're actually going to find that this graph never touches the x-axis. If it never touches the x-axis, it has no x-intercepts. If it has no x-intercepts, it has no zeros. If it has no zeros, it has no factors. So this is not factorable. Okay, but that is not true the other way around. Just because you can't factor something does not mean that it does not have intercepts. Okay, so it's a one-way street. If there's no intercepts, you cannot factor. But just because you cannot factor does not mean you have no intercepts. And this is something when we talk about other ways to solve quadratics next year, we'll see in a little bit more detail. Okay, but thinking about it in terms of why would I want to take out the 5? Well, look, if I couldn't factor 5 times n squared plus 2n plus 4, then I couldn't have factored the thing that I had to start with, right? Because if I could have found what made this 0, right, it's multiplied by 5. So I'd be able to find what made the original thing 0. Okay, so think about that. All right, moving on down. 17, I'm going to do a similar thing. I'm going to pull the greatest common factor. So that's going to be 2k squared plus 11k plus 30. So I need two numbers that are going to multiply to 30 and add to 11. I know that rule will work because the a value is now 1 now that I've essentially factored out the 2. And what I know is that those numbers are going to be 6 and 5, because if I multiply 6 times 5, I get 30. And if I add it, I get 11. If I go with the original one, the original box, Okay, you can see I get 2k squared. I get 60. So this is 2k and k. Now, how can I multiply and get 60? Yikes. Well, what I know is that actually I could do 10 and 6. If you do 10 and 6, it actually ends up working out because you get 10k plus 12k, which is 22k. So you get 2k plus 10, k plus 6. And you can see again, there's a greatest common factor. So you take that out. 2 times k plus 5 times k plus 6. Now look, this might come as somewhat of a surprise for you, and that's again understandable. Up to this point, whenever we've had an a value that is more than 1, for example in this case 2, there has not been a GCF that you could have taken out. You had to really reason through it. That is, the box is the only method. But here's my argument. If there's a GCF in the original one, where you started in your first step, then one of the factors in the end is going to have a GCF that you need to factor out anyway. So where I'm coming from is, if I'm looking at 60, right? 60 is 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, right? Thinking about, and that's the ones I can list really quick like this, okay? 6 combinations right off the bat, that's a lot of ways to pair it up. If you think about it instead as factor, and in the end, right, if you can factor from the first step, then you can factor in the last step. So I'm going to suggest, why not factor off the bat and try to find numbers that multiply to 30 instead of numbers that multiply to 60. Might be a little bit easier for you. Okay? In this one, I'm going to have to use the box. You can see that the a value, for whatever that's worth, because the variable is a, is equal to 1. So notice the -1 means the difference between the numbers is literally, they're off by 1. So it looks like it's going to be -10 and 9. Because here I'd have 9a, here I'd have -10a, and -10 plus 9 is -1. So I get a minus 10, a minus 9. Again, a is also not a good letter, because sometimes you could write your a's and they will look like 9s. All right, next one's going to work out pretty much similarly. You can see 10 and 11, so it's going to be, this one's going to be p plus 10, p plus 1. Not very interesting. Here is going to be another time where you're going to want to factor out a GCF. So 5 goes into all 3. So you could do v squared minus 6v plus 8. And then from here you could factor it as v squared, v minus 2, v minus 4, because -4 times -2 is 8. -4 plus -2 is -6. Or again, you're going to factor, and you're going to see that you're going to have to think about a little bit harder how you're going to pair it, because now you've got to get to 40 instead of getting to 8. So in the end, what you'll end up finding is you'll get 5v and v, and then you'll get -4 and -10. So this would be -10v, -20v, and then those will end up becoming -30v. You do have a little bit of freedom. You actually also could do 5v minus 20. So if I did so if I did 5v minus 20 and v minus 2, I would get -20v, I would get -10v. So you see I can get the same thing. But again, notice in that the only reason I did that was because I took the 5 and distributed it into this instead of the first. So that's why I'm again going to push you to please identify, now that we're moving ahead and we're going to continue to hone our skills, identify always whether there's a GCF that could make your answer and your life in general easier. Okay, don't divide by it, but factor it out just like this. Okay, p squared plus p minus 2. So I'd get 2p plus 2, p minus 1. This I'd factor out the 4, v squared minus v minus 2. Okay, so this would be 4v minus 2, v plus 1. You can imagine v squared plus v minus 2v for negative v minus 2. Okay, remember this is our final answer, the factored form. Okay, I'm going to come down. I'll do this one in purple. So here we're in a situation where a is 1, so I'll set up my box. Now you don't need to set up the box. If you can set up the parentheses and knock those out real quick, that's fine with me. No problem. All right, so I need to multiply to 50 and add to negative 15. How can I get 50? Well, the way that comes to mind, 3 ways real quick would be 50 and 1, which we don't want to sleep on that, 25 and 2, and 10 and 5. And immediately I notice that they both have to be negative, and 10 times 5, right, because a negative times a negative, negative plus a negative. So immediately I notice I get 10 and 5. So I have x minus 10, x minus 5. And remember, you check your work by boxing it out and showing that you get the thing you started with. All right, here you're going to get v minus 2, v minus 5. I know that because this tells me I need a positive times a positive or negative times a negative. But this being negative means that they both have to be negative. And then I know that negative 5 times negative 2 is negative 10. And negative 5 plus negative 2 is negative 7. Okay. Moving on down the line. Again, I got an a value of 1. Let me set up my box. Boom, boom. So I've got p squared minus 18. So it's going to be p. It's going to be p. How am I going to get 18? Negative 6 and 3. Because actually plus 6 and minus 3. So I'll get negative 3p and 6p. And if you had missed, watch what would have happened if I had, see how I made that mistake originally? What would have happened if I had done that? I'd have gotten 3p minus 6p, and when I add them, you don't get positive 3, you get negative 3, right? And you wanted positive 3, so I'll just flip the numbers. And notice now, instead of having negative, I'm back to a positive, and that's what I want. So always make sure everything checks out. If you're not in a rush. Okay? Finally, take out the greatest common factor. First, you check for it. This has a 6, this has a 6, this has a 6. So remember, you really want to check to see if everything is divisible by a. Because if it is, that's a good sign. Okay? And now, set this up. Boom. 6v squared and 60. But we don't do that anymore, right? Because we've now boiled it down. So what I want is I want v squared and 10. So this is a v, this is a v, this is a negative 10, and this is a negative 1. Because a negative times a negative is a positive, and a negative times a negative is a negative, and negative 10v minus 1v is negative 11v. And just note, there is some flexibility. If you wrote it like this, v minus 1, v minus 10, you would have also gotten complete full credit. But the big thing you need to do right now is, one, ask yourself, am I even in the right ballpark? Am I even in the right universe? Did I get something that's kind of looks like this, but maybe in this case, did I get 6v minus 60? Or is one of them 6v minus 6? And is there room to factor out a greatest common factor? Because that's where we're going today. So if you didn't take out the greatest common factors, but you were able to get them anyway, that's perfectly okay. But I'd recommend, before moving on, that you take a second to ensure you understand, 1, why do I do it? 2, how do I do it? And 3, how can you do it? Okay, so folks, thank you very much for watching. I hope you found this video to be helpful. We do have hopefully a Google Hangouts coming up. So I recommend that if this continues to be a struggle, you think about some of the questions you can bring into that to help you really, really understand this as we continue to move on and we continue to progress. All right. So keep at it, right? Stay positive, and remember, you can do it. All right. Thanks so much for watching. Have a wonderful day, and don't forget to love math.